Hi, welcome back to the channel. In today's lesson, we'll continue with non-parallel coplanar forces. I have a question here that can help us understand it better. Our question says a wooden frame weighing 2 Newton is hung on a nail using 2 ropes as shown below. Find the tension in the rope. Now here is the wooden frame weighing 2 Newton and is hung on a nail. Here is the nail. Now let me redraw it so that to make it easier, so that we have this is a wooden frame. It's weighing 2 Newton. Here is our 2 Newton and it's hung on a nail by 2 ropes. So that in each rope there is tension T. Here there's tension T. And uniquely, we've seen that this rope, they are hung at 60 degrees to the vertical. Here also is 60 degrees to the vertical. Now the first thing we'll be doing is we'll be resolving this tension T on both sides to the vertical and the horizontal. Now if I'm resolving from this side, let's call this T1 and let's call this T2. From this side, I'll have T1 of x, and at this side, I'll have T2 of x. And at this side also, for the vertical, I'll have T2 of y, while for the vertical at this side, I'll have T1 of y. Now, if you look at it carefully, summing the vertical axis, because for the body to be in equilibrium, in our last lesson, we said our summation of f of x must be equals to 0, and the summation of f of y must be equals to. In case you missed our last lesson on non-parallel coplanar forces, please do check the description below. We have placed a link to this lesson. And also, please do not hesitate to hit the subscribe button so that you get notified anytime we create lessons and you not miss any of our lessons. Now, for the x-axis, we have Tx of 1 and T2 of x, now in different position, so that Tx1 minus T2x will be equals to 0. If you look at it, you see that T2 of x is in the negative direction, while T1 of x is in the positive direction, so that Tx1 is equals to T2x. Now, it's just the same thing. But let's find the value of Tx1 and T2x. Now, for Tx1, since let me redraw the triangle. I have, here is the rope, tension T, here is 60 degrees, and here is Tx1. For the other side, here is 60 degrees again, here is tension T, and here is Tx2, and here is Ty2, and here is Ty1. So that from this triangle, using Coplanar, we know that my Tx1 over T is equals to sine 60 degrees. So that my Tx1 is equals to T sine 60 degrees. Obviously, my Tx2 is equals to T sine 60 degrees. So that on Tx1 minus Tx2, you see that both T sine 60 minus T sine 60 is equals to 0. So on the vertical axis, I've only done this to demonstrate that on the horizontal axis is equals to 0. We're not seeing the effect of these forces on the horizontal axis. But for the vertical axis, I have Ty1 in the same direction as Ty2. Then in the opposite direction, we have a force of 2 Newton. So that Ty1 plus Ty2 plus 2 Newton is equals to 0. Now let's find the value for Ty1 from Coplanar, also from here. Obviously, Ty1 is equals to T cos 60 degrees. And Ty2 is equals to T cos 60 degrees. So that T cos 60 degrees plus T cos 60 degrees plus 2 Newton is equals to 0. Now I have 2T cos 60 degrees to be equals to, it's minus 2 Newton. Minus 2 Newton because 2 Newton is in the opposite direction. Minus 2 Newton. So to be equals to 2 Newton. Now T cos 60 degrees is equals to 2 over 2, which is equals to 1. Now T now is equals to 1 over cos 60 degrees, which is equals to cos 60 degrees from SOHCAHTOA is the same thing as half. Cos 60 degrees is the same thing as half, so this is the same thing as 1 all over 1 over 2, which is equal to 2 Newton. So T itself is equal to 2 Newton. Thank you. With this, I know you should understand how to take care of coplanar forces, and in our next lesson, we'll be moving ahead with another question to help us understand it better. Thank you for staying with us, and do have a nice time.